Hello everyone, myself Mrs. A Doddi, Assistant Professor in Civil Engineering Department, Walchand Institute of Technology, Solapur. In today's lecture, we will study how to calculate the reactions of the connected bodies. At the end of this session, the students will able to explain the concept of the equilibrium and the students will able to calculate the forces present in the given member. So, the equilibrium force is the force which will keep the body is in equilibrium. So, it means it will act equal and opposite to the resultant force. Here in this figure we can see P and Q are the forces acting on the body and R will be the resultant of this force P and Q. E is the equilibrium force which will keep the body is in equilibrium. So, the E is the equilibrium force which is equal and collinear but which will act in the opposite direction to the resultant force. Okay. So, the equilibrium is applicable to those system of forces whose the resultant action is 0. So, that is E is equal to R. The analytical conditions of the equilibriums, that is algebraic sum of all the forces acting on the body is 0 is the law called as force law, and the moment law means the algebraic sum of the moment of all the forces about any point is 0 is called as the moment law of equilibrium. So, these are the analytical conditions of the equilibrium, that is sum of all horizontal components is 0 and sum of all vertical component is 0 and the sum of all moment is equal to 0. Now, we will see free body diagram. So, this sphere is resting on this horizontal surface. Free body diagram means the body is free from all the support. So, here we have removed this horizontal surface and we have shown the reaction which will occur due to the weight acting in the downward direction. So, here we have to show only the forces which will act on the body. Similarly, here this sphere is connected with this vertical axis and this string. Okay. So, here the reaction from the vertical axis should be horizontal and the load of the sphere is acting in the downward direction and it is connected with this string. So, the tension will create in this direction. So, it is called as the free body diagram. In simple words, the body should be free from all the supports. We have to show only the forces and the reactions acting on the body. Lamis theorem. When only 3 forces are acting on the body, then only the Lamis theorem will applicable. So, if the body is in equilibrium under the action of only 3 forces, each force is proportional to the sine of the angle between other 2 forces. So, here from this statement we can get F1 divided by sine alpha, that is F1 proportional to the sine angle between remaining 2 forces, that is the angle between F2 and F3. Similarly, F2 proportional to the angle between F1 and F3 and F3 is proportional to the angle between F1 and F2. So, we will get F1 upon sine alpha is equal to F2 upon sine beta is equal to F3 upon sine gamma. Now, we will see how to determine the forces. So, first select a joint where one known force should be there. Then draw the free body diagram by considering the joint. Then apply the conditions of the equilibrium, that is summation f of x, summation f of y and sum of moments, and find the unknown forces. So, in this problem they have asked to find out the reactions developed at the contact surfaces 1, 2 and 3. Now, we will see how to find out the reaction. So, first of all we have to draw the free body diagram. What is free body diagram? We have to remove all the supports and we have to show only the reactions and the forces acting on the body. So the sphere A, the reaction will act like this. I will call R1. It is 0.1, 2, 3 and 4 between the two spheres. Then here you will get reaction 2. At this point it will be third reaction, and the contact surface between two spheres, it would be reaction 4. The weight is acting in the downward direction. So they have mentioned as the identical cylinders. So the weight for the both cylinders is 1000 Newton and the diameter is given as 500 mm. Okay, so it is called as free body diagram. So we have to find out this reaction. As we know, we are having only three equilibrium conditions, that is summation f of x is equal to 0, summation f of y is equal to 0 and sum of movement is equal to 0. Okay, so first I will consider this sphere B. The sphere B is having only three forces, that is reaction R3, the weight W and the reaction R4. So we can apply the Lami's theorem for the sphere B. Okay, so here the inclination of this reaction R3, here if I draw the perpendicular line from this contact surface, this inclination is 30, so here it is 90, so the remaining one will be 60. Similarly for this second support, if I draw the perpendicular line from here, again it is 30, 90 and this remaining one is 60 degree. For this reaction R1, from this contact point 1, if I draw the perpendicular line, so it is 60 degree and this remaining is 30 degree. Okay. The inclination of this reaction R4, if I join the centers of these two spheres, due to the same diameter, it is parallel to the plane of the inclination. So here you will get the inclination of this reaction R4 as 30 degree. Okay, because those are having same diameter. So this radius of each sphere from the contact surface is 250 mm for the both. Okay, now I will apply the Lami's theorem for this sphere B. So here we will get, if I apply the Lami's theorem, it would be reaction R3, W is acting towards the downward direction and the reaction R4. Okay, so if I apply the Lami's theorem for this, so it is R3 upon sine the angle between these two. So this angle is how much? 30 degree. So here you will get 90 plus 30 is equal to R4. So it is sine 90 plus 60 degree, the angle between these two. So it is 90 plus 60. So the remaining is 180 minus 60 degree, this one 60 minus 30 degree, this one, okay, is equal to 1000 divided by sine 90. This 180 minus 60 minus 30 we will get sine 90. Okay, so from this equation we have to find out R3. So here we will get R3 is equal to 866.202 Newton and R4 is equal to 500 Newton. Okay. Now I will go for sphere A. If we observe sphere A, we are having 4 number of forces, that is R2, R1, this W and the reaction R4. So here we cannot apply the Lami's theorem. For sphere A, I will consider the equilibrium conditions, that is summation f of x is equal to 0, summation f of y is equal to 0. Okay. So first I will calculate summation of f of x. So here we will get minus R4 cos 60 plus R1 cos 30 minus R2 cos 60 is equal to 0. So here we will get the equation, that is R1 cos 30 minus R2 cos 60 minus 500 sin 60 is equal to 0. It is equation 1. Now I will calculate summation f of y is equal to 0. So what are the vertical forces? It is minus 1000 minus R4 sin 30, it is sin 30 R4. Then plus R1 sin 30 plus R2 sin 60 is equal to 0. Okay, so here we will get the equation R1 sin 30 plus R2 sin 60, then minus 1250 is equal to 0. This is equation 2. Okay, by solving these two simultaneous equations, we will get reaction R1 is equal to 841.50 Newton and reaction R2 is equal to 957.53 Newton. So likewise, you have to calculate the support reactions for the given force system. These are the references considered for the study. Thank you.